Hi, welcome to today's video in Helius's Solana Frontend Developer course. Today, you're going to learn how to create a movie review app on Solana. My name is Nathan Galindo. I'm a developer experience engineer at Helius. I'm based in Texas and I'm a full stack Solana developer. So please feel free to connect with me on X to ask me any questions about this course, Helius, or Solana. Today, we're going to have an overview of the project we're going to build. I'm going to teach you a little bit about serialization. And finally, we're going to build the project out together. Okay, so we're going to go ahead and get started with today's project. I'm going to assume you have all of the resources, dependencies, software you need to follow along with this course. If not, if you think you're missing something, please reference video 2 of this video series where I show you how to download everything you need. But I'm going to go ahead and move forward. So go ahead and run the course app on your local browser using the yarn dev command. I'm running mine on localhost 3000. That should be the default. It should look something like this. And within your local project repository, go ahead and under the pages folder, go to movies and drag out finished and starter. I like to drag them out side by side to each other so I can reference one as I build the other. And now what we're going to do is we're going to go onto the movies project card, click on preview, where you can see a finished working version of the application, one that I built for your reference. Now what I'm going to do is first, like always, I'm going to connect my wallets, my Solana wallet. I'm going to make sure that I'm on the testnet. I am, and that I have some DevNet Sol to sign for this transaction if I need to. Looks like I have both. Now, if you don't have this wallet browser extension, or you don't know how to get DevNet Sol, again, please reference video 2 where I show you how to do both of those things. In the meantime, I'm going to go ahead and fill out this little application. So again, it's a simple movie review app, right? It's not rocket science. It just gives us a chance to practice serializing data and setting it to custom on-chain programs, which is, really important because a lot of the programs that you're going to be dealing with when you build your own custom applications will be on-chain programs. So, what's the name of our movie? I'm just going to put Pulp Fiction, and that is a cool movie. And a rating from 0 to 5, I'm going to give it a rating of 5 because I'm in a good mood. I'm going to go ahead and submit that transaction. I'm going to sign for that. And boom, movie review sent to blockchain. We got a success message on screen, and we have a transaction signature for our submission. We can go ahead and reference that on the DevNet using the Solana block explorer. And we can see that our result is a success. Our confirmation is finalized. We have the slot number of our transaction, and we scroll to the bottom. You can actually see we have logged. Our program has made some logs saying our movie title, Pulp Fiction, our rating, and actually our description as well. A cool movie. Awesome. So let's go ahead and go back to our project. Go ahead on the movies card, click starter for me. You should see some boilerplate code like so. On your starter file, you can go ahead and just delete that boilerplate code per usual. Open up some curly brackets, open up a return statement with some React fragments. Oops, there we go. And we're going to start, like always, by importing the necessary dependencies. Now I'm going to go ahead and type them out by hand because I encourage you to also type out everything that we do in this project by hand, just because when you're learning, if you're new to front-end development, React development, and especially Solana development, it's always best to type this code out by hand because that's what really puts it in your memory. I really think so. Okay, Toast. For your information, if you've never seen this library before, I've been using it throughout this course. I'm a big fan of it. It essentially allows us to throw user-friendly on-screen notifications. This is the React Wallet Adapter library. It essentially allows someone to connect their Solana wallet of choice to our app. Now configured, I've already configured the wallet adapter in this app to accept just the Phantom wallet. Now, if you're curious and learning how to add other wallets to the React wallet adapter, I recommend you go into this course and reference video 3, I believe, where I show you how to do just that. And you can kind of configure this app on your own. It is an open source application, so feel free to take it and run with it. But for now, we're going to focus on this project. And what we're going to do is we're going to initialize our React state variables. So React is a stateful front-end framework. It means that, using certain React hooks, such as useState, we can update variables throughout the lifetime of our application. And so we're going to initialize some of these state variables like so. Whereas the purple variable is the actual variable itself, right? The actual value itself. And the green item next to it is a function specifically designed for updating this variable. And so we're going to go ahead and invoke the React library, pull out that useState hook. And because this is a TypeScript app, we're going to go ahead and specify the data type of this value. And we're just going to go down the list like so. And you can kind of just infer from the way I've titled these variables what they are. So right now we're initializing the movie description, and now we're initializing the movie title, which would of course be a string value. And this is going to be the transaction signature. So when I executed this app, when I demoed this app in front of you just a moment ago, a transaction signature appeared on screen. This is where we're going to store that value essentially. Okay, now, like I mentioned before earlier, we are interacting with a custom on-chain program. And so we're actually going to have to specify the program ID of the program that we want to interact with. So we're going to do that right now. Const program ID equals new web3 public key. And then we're going to provide a string value of this ID. You can go ahead and input that there. And feel free to paste this into any Solana block explorer. You can use Helius X-Ray for this, I believe, to just, reference this program as it's deployed on chain. Again, we're using the devnet, so you might want to reference the devnet. Now we're going to use these next 2 lines of code to access certain details about the user's wallet that they've connected to our app. So if you've been following along with this course, you've used these lines of code, I think pretty much every single project we've done. They're pretty integral when you're using user-facing Solana Web3 applications. And again, as you can see, these functions come from the wallet adapter React library. You might be able to intuit from the way these items are titled, but essentially connection allows us to get the connection string our wallet is connected to, right? So let me explain that better. Like I mentioned earlier, my wallet is connected to the testnet, right? But it could also be connected to the mainnet, right? And depending on which Solana cluster my wallet is connected to, this connection string changes, right? There's a connection string for the mainnet, there's a connection string for the devnet, etc. And so this connection string specifies which Solana cluster our wallet is connected to. This public key is essentially just the public key of the wallet we've connected to the app. And this send transaction function is, again, a function that allows us to send a transaction to the Solana blockchain, which we will use in just a moment. But first, here's where we get to, I think, one of the more unique parts about this project, where we use Borscht to create a structure for the data we want to send to the blockchain. So let's go ahead and do that. So what's the data we want to send to the blockchain? Well, like I previewed earlier, we're sending a movie review to the blockchain. So I'm just going to title it Movie Review Layout. I'm going to get the Borscht library, use that struct method, and create a structure for each variable that we're going to send to our on-chain program. I'm going to go ahead and add commas, just like so. And description. So as you can tell, we've initialized our title, state variable, our description, our rating, which we have down here, but we also have this variant. Essentially, that's just a kind of value that we want to include in our structures in order to specify, like, I guess, make each submission unique, if that makes sense. Essentially, you can kind of think it as like a primary key almost, if you're familiar with like SQL database design or anything. Like, these are the values, and this would be a kind of uniqueness factor, right, that we include into this this structure of this movie review layout we're defining. Okay, hope that made sense. If not, please go ahead and copy and paste this into ChatGPT. I do that all the time, and maybe it'll give you a better explanation. But let's go ahead and move on with the code. So right now, we're going to declare a function to actually, compile this movie review we've created into a transaction and then send that transaction to the blockchain. Let's go ahead and walk through that now. Let's go ahead and create an ES6 function. What makes it ES6? Well, we are using an arrow function. This function takes one argument, event, and oops, that returns void. And essentially, event allows us, we're using it in this case to prevent our app from refreshing whenever this function is invoked. It just improves the user experience a little bit. And now we're going to have some error handling, making sure that the user's wallet is connected to the app. And you can really put any error message you want. You can even make the error message programmatic. And I challenge you to do that on your own time. That would be really good practice, especially if you're new to front-end development. I think that'd be great practice, but let's go ahead and continue. So what are we doing here? Well, first we're creating a buffer. Okay, but why? What's a buffer? Well, let's go ahead and actually walk through what we're doing with this application. So you can kind of think of the buffer like a crate, right? Like this crate of empty space, essentially. And that raw data we want to send to the blockchain, our description, our title, our movie rating, that's just kind of like car parts in this analogy, right? Just random miscellaneous scrap metal and just like raw inputs, essentially. And this movie review layout that we created just recently, that's kind of like the blueprint of what this raw input amounts to. Okay, I hope that makes sense. So again, we have that raw input, right? That user provided data. We are using that to create a blueprint of exactly what we want to create, a movie review in this case, but in this analogy, it's the blueprint of a car, right? But when we want to send that information to the blockchain, what's easier to send, an entire car or that kind of raw input information as like scraps and parts and pieces? Well, it's probably easier to package it as, scraps and pieces, essentially. And so we're going to put that information or encode that information into this buffer, right, into this package. And then once we have it in this package, then we're going to trim it, right? Because we initially allocated 1,000 bytes to this buffer. but that doesn't mean our user is going to supply 1,000 bytes of input, right? They might supply 1 or 2 or maybe even less. And so instead of, just having all of this blank space within our buffer, we can go ahead and slice it using the slice method. And then we eventually package that into our instruction, add the instruction into the transaction, and then send that transaction to the blockchain, right? And that's kind of that last step here. So I hope that analogy made some kind of sense. If not, again, please copy and paste this code into ChatGPT and just ask it to walk you through exactly what's happening, in bullet point format. I love to do that all the time. It makes my life so much easier. Okay, so again, let's go ahead and continue. So we're creating that buffer, that package space. We're going to create a movie title. And we're going to give it title. We're going to use string interpolation, and we're going to use this, what looks like nonsense, but we're using it to add some degree of uniqueness to our movie title, because, there could be other movie titles provided, other similar movie titles provided to this app. For example, I wrote my movie review for Pulp Fiction, and maybe you love Pulp Fiction too, and you do the same, right? So in that case, we want to have unique movie titles, and that's just a quick and dirty way of adding some degree of uniqueness to our movie titles. Okay, now we want to get that, movie review layout that we created, and use this encode function. And we're going to provide our state variables essentially, like so. And then we want to write this information, encode this information into our buffer, okay? So we're inserting that raw data, serializing it, putting it into our buffer essentially. Now our buffer, now that it's filled with the user data, what we want to do is we want to truncate it so that it's only as large as it needs to be, right? So its original size allocation again was 1,000 bytes, but that doesn't mean we need 1,000 bytes. So let's go ahead and truncate it by starting at 0. We're going to start with the first index of that buffer. And then we're going to get the span of this movie review layout in bytes. And then we're going to pass that buffer as an argument essentially. Okay, fantastic. So that's how we do that. Now, this next section, if you haven't been following along with this course, we've covered PDAs previously. I think this is another good chance to cover PDAs. Essentially, PDA stands for Program Derived Address, right? So what does that mean? Well, essentially, we are interacting with a custom on-chain program, right? So let's go ahead and add that there. We are interacting with a custom on-chain program. Well, data is not stored in programs on Solana, right? So on Solana, you can pretty much categorize every object on Solana as a program or as an account. Now, it's a little bit more nuanced than this, but just follow along with me here. So programs store code. They store code or executable information, right? And accounts, they store kind of just like general data, right? Just kind of like generic data, whatever kind of non-executable information essentially. So this movie review information, that's general data, right? We want to store that in an account, and we're interacting with a program in order to do that. So what we are doing is we can say that this is our client. Hold on, let me go ahead and fix that. So this is our client. This is the code we are creating right now. This is our front end. It's going to pass some data, and this little circle is going to be our data. It's going to pass that data to our program. Our program is going to receive that data, and it's going to programmatically spin up a new account on the blockchain and store that data in that account. Now, this account is it has a program derived address, right? It's a PDA account. It's program derived. Not all accounts are program derived, right? If you create a wallet, that's not program derived. You have your public key and you have your private key. PDAs don't have a private key. Why is that? It's because they don't exist on the cryptographic curve that, essentially every account on Solana exists on. I believe this is called the ED25519 curve. Is that correct? Let me just go ahead and fact check myself real quick. Yeah, ED25519 elliptic curve. So PDAs don't exist on that curve. They essentially have a bump value where they're bumped off of that curve. The program is the owner of this PDA, and it's in control of this PDA. So, when it comes to deallocating this data or managing this data in any way, it's the program's responsibility. They're the owner. This program is the owner of this PDA. So again, we pass data to the program on the blockchain. The program takes that data and spins up a program-derived address account on the blockchain to store that data, essentially. And so our data gets stored within this PDA. Hope that makes sense. If not, Helius blog has tons of information on concepts such as these. All it takes is a Google search. So that being said, what we need to do is we need to calculate the address for this PDA. And so PDAs are, their addresses can be calculated using, let me go ahead and type this. They can be calculated using the values that were used to create the PDA. And so what's always used to create a PDA is a program ID. So like I said, this program is the owner of this PDA. Well, this program's ID was used to create this PDA's address, essentially. And within our smart contract, we specified that the user's public key was also used to create this PDA. And also, let me go ahead and actually open up those brackets right there. The movie title that we provided was used to create this PDA. All right, and let's go ahead and add a comma there, and we should no longer have any error messages. Okay, so again, 3 values are being used to calculate the PDA of this account on chain that our data is going to be stored in. It's going to be the user's public key, right, for the wallet that they've used to essentially sign for this transaction. It's going to be the movie title they provided in their input, and it's going to be the program ID of the program responsible for creating this account on the blockchain. Okay, again, hope that makes sense. Again, feel free to contact me on X or leave a comment on the video with any questions. Let's go ahead and move forward. Now that we have our data, we've encoded it into a buffer, we've truncated that buffer, and we've calculated the PDA for the account our data is going to be stored in on chain. Let's go ahead and create a new transaction object. So new Web3 transaction. This is an empty transaction object. Now we're going to create the instruction that we will add to this transaction. transaction instruction like so. And we're going to go ahead and provide the program ID that we are sending this to, the buffer, so that's the data, and the keys. What is this? So if you're new to this, if this looks new to you, creating an instruction, essentially we provide the address of the program that we want to interact with, and then we provide the data, right, that this instruction contains. In this case, it's our user provided data. And the keys is essentially a list of accounts that this instruction interacts with, right? So every single account that this instruction is concerned with, touches in any way, we have to provide information for each account. So first, our user's wallet is signing for this transaction, right? So we are interacting with that account throughout the lifecycle of this instruction, and they are a signer. They're responsible for signing for this transaction, and they're not writable. This is not a writable account. We're not exactly writing to this account in any way. Now let's go ahead and specify the PDA account that we're creating on chain. Now this account is not signing for our transaction, but we are writing technically to this account because first of all, we're creating it, from nothing. We're creating it into existence, and then we're inputting our user provided data into the PDA, right? So we're writing to it. So that value should be true. And let's go ahead and provide the public key to the system program. This is going to be a signer, this is not going to be a signer, not responsible for signing our transaction, and we're not writing to this program either. So what's the system program, right? Why are we invoking this? We haven't mentioned that before in this video. Okay, so I kind of did a mental shortcut earlier when I was explaining to you this process. So yes, our client sends this user provided data to our custom on-chain program that we specified up here in our code. Okay. And yes, a PDA is created on chain, but I think the words I used were this program creates this PDA. That's actually not true. This program, this custom on-chain program, isn't responsible for creating this account on the blockchain. It's actually the system program, right? So this program, what this actually looks like, let's go ahead and create a new object. It's going to do, I guess that's kind of, let's do purple for Solana, right? So this custom on-chain program, go ahead and reword that. Custom program is going to invoke the system program, and the system program is, I guess it's a program with special status. It was created and it is maintained by the core Solana team, and it's essentially responsible for performing very basic kind of core operations on the blockchain, such as like transfer of Solana tokens and creating accounts on chain, right, including our PDA, right? And so this system program goes ahead and creates this PDA, which our data is stored on essentially. And so that's why we include it inside of our keys list in our instruction. So now that we have our instruction, let's go ahead and add, oops, why is this, did I misspell this? Let's go ahead and add that instruction to our transaction just like that. Very simple. So that's the bulk of our business logic actually. If you actually think about it, it's a fairly straightforward process. But again, if you're new to Solana development, this, isn't immediately obvious to you. So I wanted to go ahead and create another project where we, talk about serialization and program-derived addresses. So what we're going to do now is we're going to use async logic, this try, catch, and finally blocks to essentially perform the instructions to send our transaction to the blockchain. And so we do that by create a constant variable called signature. And then we're going to invoke that send transaction function we pulled out of the wallet adapter library earlier. And I'm going to pass in 2 items, our transaction, so what we want to send to the blockchain, and our connection, which Solana cluster you want to send it to. And then assuming this is successful, I'm going to set the signature, that transaction signature state variable. I'm going to populate it with this transaction signature we got from this operation. And I'm going to throw a toast success message to let the user know that their submission was successful. And if you want, you can even console log a URL link to the transaction signature. That's not super necessary because we're going to provide a URL on the UI anyways, but do what you wish. Now this catch block is going to have code that we want to run if the code within the try block fails, right? So if our request fails, then we're going to run this code in the error block. Request, failed. Fantastic. And this finally block essentially is going to contain code that we want to run regardless of whether our requests succeed or fail. So this code will run regardless, and I like to use the finally block for resetting my state variables essentially. I think that just creates a better user experience. Okay, now lastly, we're going to create a simple list called outputs. You can title it something a little bit more semantic if you'd like, but essentially we're going to be iterating over this array to render UI elements on screen programmatically. So that case, if you wanted to, show more details about our transaction on the UI, all you have to do is just add another object like so. And so I'm going to, I feel like I'm misspelling that. Never mind. And so I'm going to go ahead and do that just like this. And I'm going to go ahead and copy and paste this URL. No need to type all that out manually. Okay, awesome. So just like that, we've pretty much created all of our business logic. This app is pretty straightforward, but the concepts are super important. So I hope they made sense to you. If not, maybe before moving on to this video, go ahead and pause it and, reference earlier parts of this video, or even take time to Google and, read a few helpful articles online about, what are PDAs on Solana, and, what is the Borscht library, and why do we use that for, pushing data to the Solana blockchain and fetching data from the Solana blockchain. In the meantime, for those of you that seem like they have a handle on it, we're going to go ahead and create the UI, probably the most fun part about this application. And so I highly recommend you type out the CSS with me. We're using Tailwind CSS to give our app some styling. It's a very, very popular, very in-demand styling framework. So, practice makes perfect. And if you can use Tailwind CSS, I promise you it's going to take you far. Okay. So, if I can even type correctly, my typing is awful today. Essentially, right now, I'm defining what width on screen my UI is going to take given certain screen sizes. Now I'm going to create a form element and I'm going to give it some padding of 4. I'm going to give it a custom background color. That's how you specify a custom color in Tailwind syntax. I'm going to give it, and I'm going to specify again its screen width on certain sizes. So that way it's a dynamically sized application. Okay, within this form, we're gonna have 1, 2, 3, 4, 5, actually 5 div elements. So 1, 2, 3, 4, 5. And let's go ahead and start with this first one. This looks like it's going to be our header. This is a flex box item justify between to space out each item to opposite ends with item center to add for vertical alignment. We're gonna have an h2 elements. That's our title. And then we're gonna give that some styling as well. Font bold, text a little bit large, and we're gonna give that text some coloring as well. You can give it any kind of coloring you want, but you know I gotta stay on brand. Okay, now we're gonna add a button. We're gonna provide some button text to make it a little bit semantic. And we're actually gonna write this app a little bit differently than I did in the finished file, and I'll explain why. But right now we're gonna add some disabled logic. So if the user doesn't provide a title or a description or a rating, then we don't wanna send it to the chain, right? I think that makes enough sense. And so let me go ahead and fix that. For the styling, because this button logic is particularly large, or the styling string is particularly large, I'm gonna go ahead and copy and paste that to save time. Now what I want you to do is on your form element, go ahead and bring down the styling like so. And above the class name property, I want you to type on submit. And what we're gonna do is we're gonna use an arrow function to invoke the send movie review function we created earlier on submit, essentially. And this button is gonna be of type submit. That's just I think a best practices way of tying or associating an action button within a form and associating that with a function that this form invokes on submission, if that makes sense. Both ways that I have on each file work perfectly fine. But I actually think this way that we're doing now in the starter file is a little bit more appropriate when we're using HTML form elements. Okay, fantastic. So that's our header. And if we go back to our local host, you should see our header just like that. Now what we're gonna go ahead and do is we're going to build out the rest of the UI. So we're gonna give this item some spacing from the top, just like so. And this is a div. And we're going to, I believe this is, this is actually an H3, my bad. And I believe this is the input form, or the input field for the movie review title. So we're gonna give that ID of title. It's gonna be of type text, so not a number. The user can only put text in this field. And we're gonna give that some styling, some custom coloring, some vertical spacing. And we're going to remove some of the default styling for input fields so that this input field kind of complements our UI. Just like that. Sorry, so this is class name, Now the placeholder, this is just a short piece of text that's going to tell our user essentially what kind of information they should provide in that text box. Now on change, very important property that we need to be aware of. Essentially, on change is going to invoke this arrow function whenever the state of this input field changes, right? So every single time I change the state of this input field, it's going to invoke this function. And essentially, we are invoking this set title function that's going to update this title React variable with, whatever information we provide in this text box, right? So if I type in apples, all of a sudden this title state variable is equal to this apples value, right? That's essentially how that works. Okay, fantastic. And this actually is going to look very similar. Each other input field that we create is going to look very similar to the one that we just created. So let's just go ahead and get started on that. Again, I'm going to type this out manually. I know you might be tempted to copy and paste, but I recommend you don't, because manually typing it out when you're learning is just the best way to really digest this information. Okay. This ID is going to be of description, of type text, of placeholder movie description, of class name, custom color, once again, PY, width full. We want to take the full width of the parent elements, and we're going to remove some of the default styling to give it kind of like some continuity with the rest of our UI. We're going to use that onChange function again, use that arrow function, and we're going to set this time the description state variable, and we're going to associate the value of this input field with the title state variable, just like so. So that way, whatever, if we decide to reset, oops, did I miss something here? Border transparent. Okay, fantastic. So that way, if we decide to reset, when we reset these state variables, when we execute the send movie review function, these input fields also are reset on our UI. Okay, let's go ahead and create that last input element together. We're going to add some spacing for the top. We're going to give it a title. What is the movie rating? Class name, italic, text small. Actually, I haven't really been giving the other titles any styling, so I'm not going to do that. Just to keep it a little bit, add some continuity in the design. But I am going to give it the rating of the ID of rating. This input field is actually going to be numeric, so type number. Its max value is going to be 5. You can really put whatever max value you want, but I put 5. It's kind of arbitrary. The placeholder is going to be movie rating, class name, custom text color, vertical spacing. Items should span the entire width of the parent elements. Remove that default styling. And we're going to add that onChange logic. And finally, the value of this input field is going to be associated with the rating. Now, we're getting an error here, and that's because when the user types this inputs, let me just fix the CSS here because it's driving me crazy. Awesome. So when the user types their input into this field, right, it's registered as a string value. And so this error message is saying argument of type string is not assignable to parameter of type number, because we've specified the type of this React state variable and it's a type number. So what we want to do is simply just wrap this value in this parse int function like that. And that pretty much takes care of that. We should not receive any more error messages. Okay, awesome. So finally, the most interesting part of our UI, and probably the scariest looking part if you're new to React applications, don't be scared. It's actually pretty simple once we break it down. So earlier we created this outputs array with values that we're going to use to populate a repetitive UI element. This is what we're doing here. So we're getting that values array. We're going to map over it. So we're going to loop over each item in this array. At the moment, we only have one item, but you could actually definitely just populate this array with more objects. You know, if you want to test it out and make this app your own, I definitely challenge you to do so. Anyways, we're going to loop over each item in this outputs array. We're going to extrapolate each value from each object. So title dependency href, title dependency href. And then we're going to actually also grab the index as well for our own purposes. So the index of each item in the array. And then for each item in this array, we're going to return a list item UI element. And we're going to conditionally populate it with an A tag and so on and so on. So let's go ahead and get started on that now. So this element has some styling. Let's go ahead and give it a custom background color as well to make it stand out from the rest of the UI. And we're going to give it some padding as well. Awesome. And so within this div, we're going to have an unorganized list or an unordered list. And we're going to grab that outputs array. We're going to map over it, open up some parentheses, and within those parentheses, open up some curly brackets in order to extrapolate these values. And then use an arrow function. And then after the arrow function, go ahead and open up some parentheses, not curly brackets, because with parentheses, we're going to do an implicit return of this UI element, and you should no longer be having any other error messages at this point. Now, because this is a repetitive UI element, we are programmatically creating it, we have to provide a title to specify its uniqueness. And we're going to use string interpolation to populate this class name property with our styling. If you've been following along with this course, this should look kind of familiar to you. And essentially what we're saying here is if this item that we're looping over is not the first item in the array, then we're going to insert some vertical spacing from the items above it. So in the case that you want to add more items, right, to the outputs array, they're formatted in a visually appealing way. Now we're going to add a p tag with tracking wider to give it some letter spacing. And then we're going to open up another set of curly brackets and do some conditional rendering. What we're saying is if this dependency exists, so if this is populated with some kind of value, then, or better yet, we could say if the length does not equal 0, then we're going to render an A tag. And an A tag is essentially allows us to provide a hyperlink to another resource. And we're gonna populate the URL with this A tag like so, using that href tag. This target and rel tag essentially allow us to open up this this website in another window. We're going to give that some custom coloring to make it stand out. We're going to give it that transition. And awesome, that's pretty much all of our code. Let's go ahead and type in the information here. We're going to truncate that to just be 25 characters long. And we're going to add this icon we've imported from Hero Icons. Definitely my favorite open source library of icons. Fantastic. And so if we look at our code, it should look pretty much identical to the code that I created in our project preview. You know, if you want to give it some different styling, make it your own, make it look a little bit more unique to, you know, what you want to create, I highly recommend you do that. I'm going to go ahead and test this app. So I'm going to connect my wallet. I'm going to provide a movie title, Finding Nemo, a movie about a son and a dad. And I'm going to give it a moving rating of, again, 5 because I love Finding Nemo. I'm going to go ahead and submit that transaction and sign for it. And fantastic, that was successful. And we can reference our transaction on the Solana Block Explorer. And there is our movie review information. Thanks for watching the video. Please feel free to get connected with me on X, to connect with the Helius team on Discord, or to learn more about Helius via our website. I hope to see you in the next video. Peace out.